Okay, here we're working with the series parallel. Here we're working with the series parallel. These two are in series. This is in series. They're in parallel to each other, but they're in series to the whole circuit. So my current has to go across both, come back together here, and then get to this one. Again, just like a series circuit, if one of these in parallel goes out, and then the whole circuit can go out. If this goes out, the whole circuit goes out. This goes out, the whole circuit goes out. So first we have to find our total resistance to find our amperage. Because our amperage, I equals E divided by R total. So we need to find R total. This is a series parallel. What we need to do first is go to the parallel, break it down, squeeze it down to one resistor to make it a series circuit. Okay, so we have to come to the end here and then take care of this first. Find the total resistance of what's in parallel, because these are in parallel to each other, and then we have to put it in series with these two. So I'm going to use R1 times R2 and R1 plus R2. So it's 10 times 15 and 10 plus 15. So equals 150 divided by 25. Our total equals 6 ohms. Okay, so what we did is we just squeezed all them down and made it a series circuit. So now we squeezed it down, made it a series circuit. Now I got a 6 ohm, and this would be R2. R2, R3, slash R3. So it's a combination, it's a parallel, so we squeezed it down to a 6 ohm. Now we made it a series circuit, so now what we have to do now is the sum of all resistors. RT equals R1 plus R2 plus R3. In our case, I'm just going to put down R4 here. RT equals 4 and 6 is 10 and 2 is 12. 12 ohms. So that's my total resistance. Now I can find my current. So it'd be 48 volts divided by 12 ohms. I equals 48 divided by 12, 4 amps. Okay. So I use this formula. This formula here, we use it on unequal resistors. So when you have unequal resistors in parallel, this is the formula you use. This is the formula you use. Okay, so I'm going to erase this here, and I'm going to put my, so this was 10 ohms, and this was 15 ohms. And this is R2 and R3. Okay, so when they're unequal resistors, we use R1 times R2, R1 plus R2. If we have more than two, then we can do it twice. Or we can also use the fractions. So, I'll go here. R total, 1 over R total equals 1 over R1, or I'm going to make this a 2, plus 1 over R3. R2 and R3. So we have to flip it, and we have to find a common denominator. So it'd be RT, and I'm going to say 30. Okay, and 30 plus 30. Okay, 10 goes into 30 3 times. 15 goes into 30 2 times. Now I can all add it. RT equals 5 over 30. We flip it, so it's a reciprocal. We have to flip it back again. So it'd be 30 divided by 5. Or let me change it. to RT equals 5 into 30, so 6 times. So that's my resistance, our total. So we can do it this way, or we can do it that way. This way, we can do it that way. I'm just giving you both ways. You choose what's easier for you. You choose what's easier for you. Excuse me. Alright. So now we found our total. We have our current. Again, if these were equal resistors, I'll go after this video. After I finish this part up. So now our voltage comes across up, and on the positive side, when it gets back to here, it's at 0. Here's our negative. Okay. So ED equals I times R. ED equals I times R. So let me find the voltage here. Let me use the blue color. I'm only going to write the formula down once. So I know my current is 4 volts. I mean 4 amps. My resistance 4 amps. 4 times 4, 16 volts. 4 times 2 is 8 volts. Okay? So that means if I add these two together, that gives me 24 volts. So that means I got 24 volts going through my parallel circuit. Okay? How do I know that? This is using 16, this is using 8. Okay? What happens when you have a parallel? What happens to the voltage in parallel? Stays the same, exactly, stays the same. So that means I got 24 volts going across here. I got 24 volts going across here. I can check it. I can check it. Because I already know that my total resistance is 6 in that parallel. My amperage is 4. 6 times 4, 24 volts. Okay? So I can check it here, and it's correct. So I got 24 volts going through here. Even though this is a series, these are in parallel. Voltage in parallel is the same. Voltage in parallel is the same. So as the 24 volts go through here, comes to here, it'd be at 0. You know, so I got 24 volts coming here, and I got 24 volts coming here. When it gets to here, it's at 0. When it gets to here, it's at 0. And it used up. So the only thing left is 8 volts to get it to this, to get to 0 here. So now, because this has its own voltage, let me erase the 24 here. Because this has its own voltage, well, this one has its own amperage also, because they're in parallel. It's a total of 4, but this is going to have so much, and this is going to have so much. So, what is my current here? Let me get the red. Again, I equals E divided by R. So 24 divided by 10, I equals 2.4 amps. Okay. 24 divided by 15. My calculator. Go. 24 divided by 15 equals 1.6. Okay, 2.4 plus 1.6 equals 4 amps. Equals 4 amps. Okay, series parallel. Talk about it. You got a couple of questions. It's not very hard. So it's just make sure you understand the formulas, where you start off first. You always start off on the parallel, squeeze it down to 1, find your total resistance for whatever's in parallel, make a series circuit, it's all done. Okay, in parallel, voltage would be the same. So each one has whatever voltage is left over from these two, it's going across both of them. Okay, so now I get my 24 volts. I divide it by the resistance. That gives me 2.4 amps. I get the 15 amps. I get 24 volts divided by the 15 ohm resistor. That gives me 1.6. 2.4 plus 1.6 equals our total current to 4. Throughout the circuit, our current would be the same, because even though they're in parallel, they're in series with everything else. Okay, so this is, again, we use this when it's unequal resistors. We use this when it's unequal resistors. When they're equal resistors, we use something different. So let me get my cleaner here. Erase some of this off. Volts, 4 ohm. Okay, I'll make this 12 ohm, 12 ohm. So they're equal resistors. They're equal resistors. So the formula, when you have equal resistors, R2 and R3, R1 and R4. Okay, so when we have equal resistors that are in parallel, when we have equal resistors in parallel, it's R of 1 divided by the number of R. Okay, so here, the resistance of 1 is 12. How many are there? 2. Okay, so my R total equals 6 ohms. My total equals 6 ohms. I'm not going to go through all the math again because it's all the same as the last one. Okay, that's why I try to make them equal, where it would come out to 6 ohms just like our unequal parallel did. Well, and then once I may break those down again, I'm making these, I'm squeezing them down. Now I got a 6 ohm resistor, so I don't have this one here. I only have the 3 on the outside, for 4 plus 6 is 8, and 2 is 12. I mean, 4 plus 6 is 10, and 2 is 12. So I got a total resistance, R total. So I got an R total of 12 ohms. So it's R1 plus R2 plus R3. I equals E divided by R total, 48 divided by 12. I equals 4 amps. Okay, I equals 4 amps. Going across here, voltage drop, ED equals I times R. So 4 times 4, 16 volts. 4 times 2 is 8 volts. 8 and 16. Okay, well, I can come over here. 4 times 6, that means I got a 24 volt going through my parallel. Okay, I got 24 volts going through my parallel. I equals, E divided by R. So 24 divided by 24 divided by 12 is 2 amps. 24 divided by 12 is 2 amps. 2 plus 2 equals our total current of 4 amps. I hope this is helpful. So if you have any questions, go back, look at the video. Just like I did for the series and I did for the parallel. Here's a video for the series parallel. It's not hard. This one is, we don't use it. The more important one is a parallel, because that's what we do use to wire buildings, houses, buildings, and everything else. These are used in specialty things, you know, so you have things that are working alongside with one another, and if one breaks, the one stops, and then you want all of it to stop. You know, so we have a safety locks, like when I worked at the meat processing plant, slaughterhouse, we had switches, that were in series, and as thing moved along, well, if one stopped working, it would stop the whole thing, because they were all working in conjunction with each other. So this is how something like this would work. Okay? Good.